Assalamu alaikum everybody, this is Mr. Mudaffir and this is another lesson in ICT system lifecycle, and in today's video we're going to talk more about, we're going to actually study for the first time development and testing, which is the third stage in the system lifecycle. So let's get to it. Alright, so we did our analysis, we figured out where the problem is and how we can improve the system, and then we designed the software or the new system, whether it was a software and hardware, or whether it's just a software, or whether it's in general a new system. Now we're going to test the system that we have created. Once the design stage is complete, it is then necessary to create the system and test it fully. This section considers some of the development stages and testing strategies that are often adopted by system analysts. All right, now in order to develop and test, what are you going to do? If the system contains files, for example, a database, then the file structure would need to be finalized at this stage. What type of data is being stored in each field? The length, decide on which field will be decide on which field will be the key field, how many, how will the data files be linked. Now, I'll explain to you later what is key field is, all right? Once the file structure has been determined, it is then created and tested fully to make sure it is robust when the system actually goes live. Okay, the next point is, since it's important that the correct data is stored in files, whether it's files, whether it's a database, or so on. So there are certain techniques that needs to be adopted to make sure the data population, the data populating the files or database is at least of the right type, and that it conforms to certain rules. The validation routines, the verification methods are used to ensure this happens. Now the next point is, obviously any system being developed will have some form of user interface. Uh, okay, let's talk a little bit more about what is a user interface. Let's point out the most popular softwares that we have on Earth. For example, Microsoft Windows. Microsoft Windows is a software, and what you see in front of you is called user interface. This is what you see once you get once you open Windows, right? This is the start. This is the taskbar, and this is the start menu, and this is the file explorer to which you can see your files. This is the explorer that shows you your files. You have options here. You can navigate from one folder to another or one disk to another. What you see as a user is called user interface. So obviously any system being developed will have some sort of a user interface. The types of hardware already have been considered. What are we going to need? Laptops, tablets, the types of hardware. How these are used to actually interface with the final system now needs to be identified. For example, how the screens or any other input devices, for example, some systems require barcode reader, some systems require a camera for a face recognition security system, or a fingerprint system, and so a fingerprint device, and so on. We will use to collect the data and the way the output will be presented. Okay. Now, testing strategies. Software is often developed in modular form. This is another term that we need to understand. Modular form. Okay. Imagine that you are designing a social media, and you have a team of, let's say, 15 IT people or 15 programmers. Yeah. Now, as a team leader or a team manager, I'm going to divide the social media into modules. Yeah. So I'm going to ask 5 of my team to be responsible about, let's say, friends and friends requests. Now I'm going to ask another 5 to be responsible about the feed or the wall. Okay, and then I'm going to ask another 5 to be responsible and create, let's say, the settings, the main settings for the app. Yeah. Now I have three modules over here. I will have the friends module, I will have the feed module, and I will have the settings module. And then when all those people finish their work, I'm going to grab those three models and put them together so that I could have, or I will have, the final social media app that I want to design. Now, this is what we mean by module. A module is only part of the system. Yeah? Okay. So software is often developed in modular form. Basically, every app or every software, it's being developed by modules, right? This method allows the software to be broken down into smaller parts, known as modules. Each part is developed separately by a programmer or a team of programmers, yeah, and is then tested to see if it functions correctly. Any problems resulting from the testing require the modules to be modified and then tested again. Now, the thing about modules is that if you have a problem in one module, you don't have to edit the entire software. You only have to edit and rectify that module. Yes? Once the development of each module is complete, the whole system needs to be tested. And then again, you have all the modules, you combine them together to get the app. Now you want to test the entire software as one, all modules functioning together. You make sure that the entire app or the entire software with all of its modules are functioning together. Even though each module may work satisfactorily, when they are all put together, there may be data clashes or incompatibility issues or memory issues. Then you have to rectify those. Yes. Okay. Okay. In the next figure, it shows us that this is a software that's divided into four modules: module 1, 2, 3, and 4. And we test each and every model separately. Model 1 testing, model 2 testing, 3 and 4 testing. Now we combine the entire model to give us the final program, and now we're going to test the final program. Now, modeling testing. Okay, now we have four categories: normal, abnormal, extreme, and live. When we are going to consider the first three types at this point, normal, abnormal, and extreme, let us suppose that one of the fields in a database is the date. Let's suppose that we have the date field in a database, and a date must be in the form of day, month, and year. They all have to be numeric numbers, right? Now, if the testing is normal, then this is data that is acceptable. Everything that you entered that is acceptable, then it's normal, right? This is data at the limits of acceptability. For example, the extreme values of month can be either 1 or 12. If it was days, then it can be 1 or 30, for example. We call that extreme. Then you have abnormal. This is data outside the limits of acceptability or the wrong type of data and should be rejected or cause an error message. For example, all the following values are not allowed as inputs for the month. Negative numbers, -1, -15, that's abnormal. 32, 43, values greater than 12. They are abnormal. Letters or other non-numeric data, for example, July, abnormal. Non-integer values, non-integer values, for example, 3.5, 10.75, they are abnormal. Yes? Okay. Let's assume that this is a form, and those are the input that was entered by a user for a month. Let's assume it's a month. Okay. Now, if the user entered 15, it's normal. Is it? We don't have a month that's 15, so it's going to be abnormal. Maximum is 12, right? From 1 to 12. Now, if the user entered 12, then it's extreme, because it's the last number in 12. It's at the range, at the edge of the range. 7, normal. 1.6, abnormal, because we don't have a month that is 1.6, right? It's totally not acceptable. 0, abnormal, because it's not acceptable. 1 is extreme. When we're dealing with month 1 and 12 are called, they are extreme. March, abnormal, because we're using only digits or numerics, right? 10 is normal because it's between 1 and 12. Yes? All right. Now, we're done with the development and testing. We're moving to the fourth stage of system life cycle, which is implementation. Now we analyzed, we designed the system, we tested it, we checked if there are errors or so or so. Now we're implementing the software. Now in this stage, in the simplest words, I can tell you that we're giving the software to the people. We are installing it on their devices. We're downloading it. We're installing it. We're actually at this stage we can also train the employees how to use it and everything, right? Once the system is fully tested, the next stage is to fully implement it. Some of the stages in this process are shown in the figure. Okay, there's a need to train staff on the new system. This is one step in implementation. The next step is transfer paper files or electronic files to the new system. You can copy the data, you can key them in, you can scan them, you can key them, you can download them to a new database. This is the verification that we use. We copy the old data to the new system, right? Okay, now changeover. Now this is what we're going to study right now. Changeover from the old system to the new system. We have four types of changeover: direct, parallel, pilot, and phased. Direct, parallel, pilot, and phased. Now let's go and read about those four changeovers. Now we want to implement it, but we're not gonna just say, let's do it, right? We have to decide on which method we're going to use. Okay, now let's assume that we're going to change from new system to old system using the direct changeover implementation method, right? Now, what is direct? Direct is, with this method, the old system is stopped overnight and the new system introduced immediately. Now, I'm going to give you the software and you guys start tomorrow, you start using the old system, the new system overnight. Full stop. Yeah, we're not going to change everything. We're not going to wait for anything. We're just going to change it right away. Now let's read about the advantages and disadvantages of this method. This method can be disastrous if the new system fails since the old system is no longer available. So if I gave them the software and we changed it from the old system to the new system overnight, and then we wake up tomorrow, we go to work, and then the system is not working, then my work and my business is going to stop, right? I'm not going to be able to work. So this method can be disastrous if we have any trouble with the new system. The next one is the benefits are immediate, and that is an advantage. The benefits are immediate. They're going to have a new system overnight. It's going to be very fast. It's going to be time saving. It's going to be very quick and neat and nice and organized. Yes, the benefits are immediate. The third one is costs are reduced. It doesn't cost a lot of money since I'm going to be changing the system overnight, right? The system used, there's no need to pay for two sets of staff. I'm only going to have one staff that is using the new system, and that is an advantage. The last one is less likelihood of a malfunction since the new system will have been fully tested. Now, I already tested the system in the previous state, right? So probably it's not gonna break down once I install it, right? So that's another advantage. Now, the next method of implementation is parallel. Now, parallel is more secure, but let's see what is parallel in the first place. With this method, the old and new systems are run side by side for a time before the new system takes over altogether. Now I'm going to have two systems. The old one, the one that they were using, they're going to keep using that, but then I'm going to give them the new system and they're going to use it side by side with the old system, right? Now let's read about the advantages and disadvantages of this changeover. If new system fails, the old system is still available as backup. Yeah, that's an advantage. If my new system fails, I still have the old system to work with. So my work is not going to stop because my system fails, right? That's an advantage. It is possible to gradually train staff. Now, I have the old system and the new system working together. I can pull out one employee after the other so that I can train them how to use the new system. That's another advantage. I can possibly to I can it's possible to gradually train staff. Now the next one is it's more expensive than direct since extra staff are needed to run both systems together. It's more expensive because I'm going to have people who are using the old system and I'm going to need more people to work on the new system. So it's more expensive. I'm going to pay both those employees, right? Now, the last one is it's also more time consuming than direct since data needs to be entered into two systems. Whatever that I'm going to do in the old system, I'm going to have to do it in the new system. So it's time consuming, right? And that is disadvantage. Moving on to the third type of implementation method is pilot. With this method, the new system is introduced into one branch or office of the company and its performance assessed before being introduced elsewhere in the company. I've given examples of Zain or MTN or Sudani or Verizon or whatever companies that has more than one branch. In the pilot changeover implementation method, we're only gonna apply or implement the system into one branch and then we're gonna assess it. Yeah, let's read about the advantages and disadvantages of this changeover method. If the new system fails, only one part is affected. The remainder is unaffected. Yes. So if the new system fails, only one branch is going to stop, but the rest of the branches are still operable, right? Operational, right? It is possible to train staff in one area only, which is much faster and less costly than parallel. Where in the branch where I implemented the new software, I can train the staff over there, only the staff over there, right? Uh, that's why it's less costly than parallel because I'm only going to have one staff working I'm only going to have one part of the people or one group of the people working on that system. The costs are also less than parallel since only one part of the system is being introduced. One part of the system is being used in the pilot warehouse. It costs a little less or a lot less than parallel since only one part of the system is being used in the pilot warehouse. Now, the next one is phased. What is difference? What is the difference in phase? With this method, only one part of the system is introduced. Now, what do we mean one part? You can say that we applied only one module, the one that we spoke about earlier. If it's a social network, I'm only going to apply friends first. Yeah. And then if it's working perfectly, then I'm going to move to the feed. If it's working perfectly, then I'm going to move to settings. I'm gonna apply only one part of the system. I'm going to introduce that, and then only when it proves to work satisfactorily, then I'm going to go and introduce the next part, and so on until the old system is fully replaced. Yes. Now let's read about the advantages and disadvantages of this method. If the latest part fails, it's only necessary to go back in the system to the point of failure. Hence, failure isn't disastrous. If I have if one part of the system, I'm only going to have to go back to the point of failure. Now the next one is it's more expensive than direct since it's necessary to evaluate each phase before moving to the next stage. Now I'm going to divide the software and then I'm going to test and assess each and every part of it, right? That's why it's more expensive. And it also could take a lot of time. Now, it's very time consuming since each part needs to be fully evaluated before making any further changes to the system. The last one is it's possible to ensure the system works properly before expanding. It's very clear, right? All right. In the next video, we're going to go through the fifth and the last one, the fifth and the sixth, which are those two are the last one that we have in the system life cycle. Well, I hope everything was very clear. See you in the next video. Take care.